Hello everyone, welcome back to our channel. This is series 26 dealing with different innovative ideas used for project planning, research phase and idea pitching. Please be interested to know more about the innovative ideas and stay tuned for all the information in our channel. Come, let's go into the video. The first topic for today is root zone sensing for real-time nutrition absorption feedback. Yes, the root zone involves an embedded smart sensor into the soil or hydroponic substrate at the root level of plants to monitor the key parameters like pH, electrical conductivity, temperature, moisture, and nutrient ions concentration. This sensor provides a real-time feedback on the nutrition absorption condition directly at the plant's root interface, where the nutrition uptake actually happens. By integrating this data with IoT-enabled control system, greenhouse automation can dynamically adjust irrigation schedules, nutrition dosing, and environmental condition based on plants' actual uptake and needs, not just fixed schedules. Moving on to the innovation features and future scope, the first one is precision nutrient delivery. So this automatically adjusts the fertigation, that is fertilizer plus irrigation rates based on actual nutrition absorption. Closed loop feedback system. So the root zone sensors provide real-time input to control algorithm, say for example fuzzy logic or PID for continuous optimization. IoT plus cloud integration. So the nutrition trends and root health data are uploaded to the cloud dashboard for remote analysis and ML insights. Multi-depth sensing arrays. So the sensor at different soil depths detect the nutrition movement and absorption pattern over time. Early detection of nutrition lockout or toxicity. So the alert the system or farmers before deficiency or excess become visually noticeable on the plant. What would be the future scope? AI-based nutrition forecasting. So it uses the historical root zone data and weather patterns to predict future nutrition needs and prevent yield losses. Plant-specific root signature analysis. So this develops the models that recognize unique nutrition uptake patterns for different groups of crops or even varieties. Wireless self-powered sensor networks. So using energy harvesting, it might be solar or microbial fuel cells to enable long-term maintenance-free operation. Integration with autonomous farming robots. So the data from the root sensors can guide robots to selectively apply nutrients or identify underperforming zones. Blockchain linked fertilizer usage logs. So this creates a transparent and verifiable fertilizer usage records for organic certification or traceability. Climate adaptation feedback. So this adjusts the nutrition strategies dynamically based on extreme temperature or humidity fluctuation to maintain the plant resilience. Moving on to the next topic for today, next generation organic tiles for net zero architecture. So here the next generation organic tiles refers to eco-friendly building tiles made from biodegradable or sustainable organic materials like cow dung, agriculture residues and natural fibers engineered to align with net zero architecture, building that produces as much energy as they consume and have minimal environmental impact. These tiles are not just sustainable in material but also manufactured using low carbon or carbon neutral methods such as sun drying, low temperature kilns or biobinders instead of cement. They offer a key construction features like thermal insulation, acoustic damping and durability while being biodegradable or recyclable at the end of the life. What would be the innovation highlights and future scope? Cow dung based composition. So this utilizes cow dung which has natural binding, antibacterial and thermal resistance properties. Natural fiber reinforcement. So this is mixed with rice husk, jute, coconut fiber or hemp to increase strength and reduce cracking. Low carbon manufacturing. So here this uses solar curing, compositable binders or low energy clay firing techniques. Passive climate control. This provides thermal insulation, reducing dependence on air conditioning and heating. Decorative surface treatments. The natural pigments and organic sealants create visually appealing toxin-free tiles. Water repellent and breathable. It means it is treated with eco-friendly coatings like lime or neem oil to resist water while allowing the airflow. What would be the future scope? Yes, integration into smart buildings means smart sensors embedded in tiles for humidity, temperature or VOC monitoring. Biotiles for carbon sequestration. So this is nothing but incorporating algae, fungi or biochar to capture carbon during tiles life cycle. Scalable modular tile system. The interlocking eco tiles for fast DIY construction, especially in rural or disaster prone areas. 3D printed eco tile design. It means the customized organic tiles using bio ink from cow dung and crop waste via additive manufacturing. Energy generating eco tiles. There is a hybrid with solar or piezoelectric elements to contribute to the building's energy needs. Then commercialization for LED and Griha certification means the tiles can contribute to green building ratings, encouraging the use of urban eco construction. What is the next topic? Automatic filament spooling with tension sensing mechanism. So in 3D printer filament extruder, once the molten plastic is cooled and solidified into filament, it must be neatly spooled for storage and later use in 3D printers. The manual spooling often leads to inconsistent winding, filament breaking or tangled rolls, especially when extrusion rate varies. An automatic filament spooling system with tension sensing solves this by automating the winding process and using real-time feedback to regulate the spool speed based on filament tension. Tension sensors such as a load cell, strain gauge or spring-loaded arm ensures a filament is wound smoothly without slack or breakage. What would be the innovation highlights and then the future scope? First one, real-time tension sensing. This uses mechanical or electronic sensor to measure the filament tensions as it exits the cooling zones. Closed loop control system. So a microcontroller, maybe Arduino ESP32, dynamically adjusts the spool motor speeds to maintain the constant filament tension. Filament guide arm. This oscillates to ensure even layer by layer winding across the spool width. Emergency stop for snag detection. So this auto halts the motor if the tension spikes, preventing the filament snapping. Smart calibration. So this adapts to different filament materials like PLA or ABS and different diameters. Compact integration. This is designed for compact low-cost extruders using 3D printed parts and off-the-shelf components. Moving on to the future scope, IoT enabled spooling system. So this monitors the spool tension, speed and fill level via mobile app or cloud dashboard. Multi-spool auto switching. So this automatically switches the spools when one is full, ideal for continuous production. AI-based spool pattern optimization. So this uses ML to prevent crossovers or tension spikes in complex spooling pines. Battery or solar powered modules. So there is a portable units of off-grid, disaster relief or educational use. Filament quality analytics. So this integrates with laser diameter sensors and thermal cameras to monitor filament quality during spooling. Industrial grade integration. So the scale the design for use in commercial filament extrusion plants to reduce the labor and waste. Moving on to the last topic for today, smart biopacking with bamboo nano indicators for spoilage detection. So this concept involves the development of intelligent biodegradable food packaging made from bamboo nanocellulose biocomposites embedded with nanosensor or natural spoilage indicators that change the color or signal spoilage in real time. So the packaging doesn't just store food. It monitors its freshness by detecting the factors like pH, temperature, humidity, or gas emission. The bamboo nanocellular matrix provides a strong, flexible and eco-friendly base materials, while bioindicators, that is for example anthocyanins, curcumin or pH responsive dyes integrated into a film respond to a microbial activity or chemical change, visually notifying the user when there is the food can no longer be safe. What would be the innovation aspects and future scope? Bamboo nanocellulose reinforcement. So this enhances the mechanical strength, barrier properties and biodegradability of the film. Colorimetric spoilage sensor. So this incorporates natural, non-toxic dyes that shifts color based on food freshness indicators like acidity or gas level. pH responsive packaging layers. It means this enables a real-time freshness monitoring for meat, dairy, seafood or produce. Fully biodegradable smart film. The entire structure is compositable and safe for direct food contact. Next to the future scope, wider application spectrum. So this is adapted for packaging perishables, ready to eat meals and pharmaceuticals. IoT integration. So this pairs with the QR code scanners or NFC tag to send spoilage alert to the smartphones. Multi-sensing capability. So the advanced version could detect the pathogens, oxygen levels or UV exposures. 3D printable smart films. This develops a custom molded smart containers for specialized food items. Commercial scale-up. So this uses agro-industrial bamboo waste for mass production of smart films at very low cost. So you're interested to know more about interesting topic? Yes, please stay tuned for more information. Thank you.